Hi, everyone. Thanks for the nice introduction. I actually have a lot to talk about, and potentially 20 minutes are not enough. So I have some slides I'm going to walk you through. So potentially we need to speed things up, because I also want to show you some coding, because we are at the developer conference. Okay, so what we're going to talk about? We talk about CAP performance, and I think that's an issue everyone kind of can relate to. I'm actually going to showcase two CAP plugins that I'm building or have built, or I'm still building. One is cds-data-replication, the other one is cds-caching, that try to solve some of those issues. And yeah, that's like the agenda. Let's go quickly through this. So before we actually start, I want to just point out that open source rocks. So all of those plugins are open source, so you can check them out on GitHub. You can use them freely. Also, I presented CDS Kafka in another talk. It's also open source. There are many, many other cool things available. Like if you go to best of CAP.js.org, which is maintained by Marianne Zeiss, you will find also another super cool CAP plugins that you can use in your projects and make this awesome CAP framework even better. There's also like some quotes. So even if there's no money for you, if you engage in open source, there's some really cool feedback. So those are some LinkedIn messages that I received, and that actually make me proud when my solutions can help others as well. So shout out to Jörg, who's sadly not here from Australia. He will be here next year again. All right, so let's go into this performance. When you look at performance issues, like CAP is a framework running in the web, so you actually have clients that are apps or UIs or other services that connect to you, and they want to have data, and then you need to respond fast, right? So, but there are like some problems that can occur, some challenges that make you slow. So if you like have heavy processing inside of your app, you do some complex tasks, then things slow you down. Or one of the cool features of CAP is you can easily access remote services and merge them with local data. But if the remote service is slow, then your app will become slow. Also, if you have like complex database queries, things will slow you down. And so the first thing you should do is to get at the core problem and try to fix this, right? To actually solve this. But this is sometimes not possible. So especially when you talk about remote services, then you're not the owner of that service, and you can reach out to them, but potentially they cannot fix this. So you have to live with it and find workarounds to actually work with this. So let's discuss two options: caching and data replication. In theory, caching is rather simple. So what we're actually going to do is we introduce another layer into our architecture that is basically a cache. So a simple key value store where I can store some of the heavily processed data under a certain key, and if the next request comes, I can read out the key, fetch the data from the cache, and it will be lightning fast. So the first processing time would still be slow, but all the other requests, yeah, they will be fast. So while in theory this is actually quite simple, caching itself is not that simple. And there's like a famous quote, and you cannot talk about caching without that quote. So I actually use the slight variation because I think it's even funnier. There are like two hard problems in computer science: cache invalidation, naming things, and off-by-one errors. Okay, so the other idea to actually solve this problem is through data replication. And while this does not tackle all of those three problems, it mainly addresses the slow remote services. So instead of like going through and fetching the data at runtime all the time, you actually create local copies, right? So you replicate the data to your local database to avoid calling those slow remote services all the time. This does not only solve a performance issue, but while remote service support in CAP is awesome, there still are some limitations to this, right? So if you want to mesh it up with local data, you still can see in the table, there are some things that don't work quite nicely, or you have to actually go into the coding by yourself to read the data on your own. All right, data replication with CDS data replication. So actually I applied for 40 minutes, then I would go a little bit more, would have gone a little bit deeper into this, so I only have 20 minutes. So just a brief explanation what this is. It's a CAP plugin, and it's actually designed to leverage some cool built-in functionality in CAP and gives you some nice replication tooling at hand to easily replicate data on your own. Actually, interestingly, I yesterday talked with Gregor, and he has a use case. He built some stuff on his own. I also saw other people doing this, and it's not that complex in CAP itself, but cds-data-replication will give you some nice tooling around this that will help you. It's sadly not yet released, but I will release it sometime this summer whenever I have little time to spare. So in theory, it works like this. Actually, practically, it was like this. So everything in CAP is a service. So this still is not something new. So in this scenario, we have a database service and an external service. So we define this in the package JSON. That's the way it is. And what cds-data-replication brings to the table, there's one option to use it, is a little bit of annotation telling the service that we have like an external service, we have an entity called business partners, and we want to replicate this into our local database. And if you apply this kind of configuration, you can see actually we also have some sort of delta tracking, so we can replicate the full data, or if this is supported, we can also like use timestamps to only refresh data on, that is updated in the meantime. And if you apply this, then basically you're almost ready to go. Then you have a third optional step, and I kind of applied the principles that CAP already provides. So you can like hook into the replication service and do only this necessary stuff that you want to do or need to do to modify this. So in this scenario, we actually apply a filter to the request and say we are only interested in business partners from the industry tech, and we potentially want to do some advanced mapping, and then you're done, because the rest is handled by cds-data-replication, which I think is pretty cool. Okay, but that's just a teaser. Again, whenever this is fully done and fully tested, I will write a blog post, and you will have the repository on GitHub and can try to use this. Okay, so but the main focus would be on caching. And before I jump in, I actually released CDS caching as a plugin at the beginning of the year. And as you've seen on the quote, so it's already been used. I tried to release version 1 prior to this event. I have said this in the other talk as well. We're all developers, we know how this works, so it will potentially release next week. Yes, what it is, it's a CDS service-based implementation, so we'll have another service inside of your CAP app. And it's basically a simple key value store, but what I really try to do is to attach it to the core principles of CAP. Right, so it's easy to use, but it also has advanced CAP integration through a mechanism called read-through caching, and I'm going to show you what this means in a second. And it has advanced caching features like this time to live support, so you can invalidate cache based on timings. There's tag support, compassion support. Version 1 basically introduces performance metrics, so you're also able to actually analyze what's going on inside of your cache to see if this is working out for you or not. And again, it will release soon. Before we jump into the coding, and I'm going to show you some coding examples, let's quickly go one last slide in theory. So there's read-aside and read-through caching. Read-aside basically means that you use the cache as a simple key value store. Right? So you are doing this stuff all on your own, you're requesting the data, executing the stuff, and you simply write and read from the cache by yourself. So this is useful if you want full control over your keys, over the data that's stored inside, but it's also up to you to actually do this. CDS caching also supports read-through caching, which means that you delegate some stuff down to the caching service itself, and it will actually take care of storing the data, reading the data from the cache. So basically what you need to do is just call run, send, rep, and exec. So that's methods that the CDS caching service provides, and then you're ready to go. Okay, so yes, I have 10 minutes time, which is cool. Okay, so let's look into some code. Okay, what we're going to do is, I'm going to show you several use cases on how this can be done. So starting from very easy things to more complex things later. So we will actually leverage, and we all learned from DJ Adams, how to use CDS REPL to actually launch the terminal, and I hope it's big enough for everyone to see. Yes, I think so. And so let's look at this first. So on the configuration side, what we actually do is we integrate CDS caching as an NPM module, and then we basically configure this as a service. And when we go through this, in our example app, we have the database, we have an external service, which is the Northwind, famous Northwind service, and I actually have 2 caching services, and that's also like something that I should enforce you to do if you're using this. You can create multiple instances of the service, and you should separate caching requirements, because then it's a lot easier to maintain. So I have a central caching mechanism, and this also shows like you can have different caching backends. So in this scenario, I'm going to use Redis as a caching backend. So I have a local Docker instance of Redis running locally. But there's also like other support, like you can also use SQLite. But I would advise everyone, if you go to production, then use Redis. And Redis is also available as a service on BTP, so you're basically ready to go. All right, so since we have now everything in place, I can simply connect to the service and get some feedbacks that I'm now connected to Redis. And then you can start caching, okay? So the caching circuit itself, as I said, the basic operations are relatively simple. So in the first scenario, let's execute this. We will basically just store my value under a key called my key. That's not very complex, but it's now stored in the cache itself. To actually retrieve a value from the cache, you will actually do this, and then the value will be returned. So it's rather simple. Okay, so if you want to delete this entry, so it will stay in the cache forever, because we don't have specified other things. Like if we want to delete this, we can simply call delete, and if we now try to read the value again, it's gone. So super easy. But yeah, then comes the complexity into this. So when do we want to delete something? So it's not good to store data for an endless amount of time into your cache, because the data might get stale, it's not updated anymore. So how do you deal with this? And there's some built-in functionality that's not the solution for everything, but potentially it helps you a little bit. It's time to live support, right? So you can simply use this. And let's grab the value a couple of times, and after 5 seconds, you can actually see that the value is gone. So that's built in, so you don't need to take care of this yourself. When the amount of time is done, the value will be removed from the cache. Okay, so that's like the simple part. So in these scenarios, you would actually be responsible to read the stuff by yourself, provide the key, provide the value, and store everything in the cache. So that's read-aside caching. But there's some more advanced stuff available. So when we have this query, we want to execute select from app service foo, and basically I have a service, and then there I have like a little bit of some entities here, and I just want to grab them. I can query this. And if I do this, again, I would execute this, store the data, store it in the cache, read it from the cache, check if the data is there, and if not, write it to the cache. But the caching service itself provides a run method. So it's kind of similar to the run of CDS or the database service. And when you use this and pass in the query and the service it should be executed against, then this will all be handled by the caching service itself. So let's execute this. And we can basically see that we get the result back. So we can do this multiple times. And I tell you that in the background, the caching will be used, but it's like we create a database, we don't see any outcome to this. Therefore, like version 1, and it's not available in the recent version, but it will be available in version 1, I introduced a read-through namespace where you have like a more or a better version of this run method. So if I execute this, you can actually not only get the result back, but you will get some metadata back. Because also if you do read-through caching, you're not providing the key. And potentially, you need to have the key at hand because you need to, I don't know, do something with it, delete it, etc. So if I execute this the first time, you would actually see I get the result back. I get the generated cache key back, which is like a hashed value of this query. And I get some metadata if this cache hit or not. So if I execute this now multiple times, you can actually see, oh, it's now hitting because we store the value for like 5 seconds in the cache, and it's not querying the database, it's just delivering the value from the cache. Okay, so this not only applies to database queries, but this also applies to requests. So for this, or no, just one prior step. By default, the cache key is generated through caching only through the inserted query or request information. But if your app supports like authorizations, or you have different locales, or even multi-tenancy, then you want to have this part of your key because you don't want to potentially deliver the same data to all tenants or to all users. So for this scenario, you can also override the key. So for this, we just set the context in cds-repl. So in your normal application, you would have this context available. Right now, we set it. And then I can actually manipulate, or not manipulate, I can configure the key to actually include some aspects to this, right? So I can say, like, I want to have the locale and the user as part of my hash. I don't support multi-tenancy, so I don't need it, but I want this to be part of my hash. So if I just do this, you can actually see that the cache key generated will now contain this information, and it's dynamically applied to the cache key at runtime. So again, and this also works if I do this multiple times, you can see now it's true, and we're delivering stuff from the cache. So we're still like fetching data from the database, which is not really a performance improvement, but we can also do this with remote services. So what we're going to do now is, I have actually mapped the products, and let's skip this through, the products entity of the remote services of this Northwind service to my local products endpoint. So, and when we do this, you can actually see real stuff going on. So the first hit, it takes about 1 second, which is not that slow, but it's still like there's a delay to this. So if I execute this again, there'll still be some latency, and if I do this now, you can see we're delivering from the cache the same result, and it's a lot faster because it only takes 2 milliseconds instead of like a second or so. So that's like a really big improvement. And you can also like call this directly. So we can go to the Northwind, looking at the time, I just speed things up. Or we use send, and that's basically send from methods like run and send to actually directly send a request to this OData service and cache it. So let's do this again. Again, we have latency, and now we don't have any latency. Okay, so that's how it actually works internally. 2 minutes left. So what I want to show you, another feature that I actually added in version 1, and this is metrics. Okay, so you actually kind of, potentially one other thing that I want to show you, is you can do this on coding, but you can also do this without any coding at all. So CDS caching also supports annotations. For example, I have annotated this cached entity, and whenever a hit from an OData service to this cached entity will be done, the caching will automatically be taken in the background without any sort of coding at all. Okay, so to analyze this, like this is like complex stuff that's going on underneath, I actually introduced metrics, and those need to be enabled at runtime because we generate additional data, we don't want to slow things down. But to quickly show you, all the stuff that we have done recently were actually captured in the background. And I can get a nice overview of how this actually is performing. So just quickly go over this. I can see that I have a hit ratio of 62%. So almost every second, or 60% of the hits of the requests actually have hit it. And this is like the latency comparison. So if I have a cache hit, it only takes 2 milliseconds to respond to this, which is quite fast. If I miss, it takes, on average, 500 milliseconds. So we're about 200 times faster than delivering stuff not from the cache. So, and this is like also visualized here. So this is the amount of time we take on-cache hit. This is if we call the remote service, so it's really a lot faster. And this gives you basically the opportunity to actually look at this, also not only on the total level, but also on the key metrics level. So you can actually check out the keys and look what's behind the keys and see, okay, what took very long. So this took very long, and this was our first request. You can look at some metrics here, and you can actually see like the cache key that was used, and also some of the metadata, what is behind this talk, this call, to actually really look into your application and see how you can enhance the caching of your application. All right, so I just made it in time. I hope I could give you some insights into the power that CDS caching brings to the table. It can really be a game changer, but it should not be just thrown in, because if I request cache and OData service, then I really need to think about the data update frequencies and stuff like this, cache invalidation. Okay, so that's it for my talk.
Thank you so much. Speed was of the essence, wasn't it?
Yes.
All right.